Hi team, all the best, going live now.
So good morning, good afternoon, or good evening, everyone who have joined this webinar today. Thanks for joining us in this webinar. This webinar is more on the AI governance in action. You would learn about how to create a secure, responsible, and trustworthy AI system and what it takes. The prelude to that is with the advent of AI that's coming up, especially with Gen AI and a lot of applications imbibing that into their application and enhancing it further. It's even more important to understand what comes with it, what are the risks associated with Gen AI. So today we have a couple of speakers who would actually put light into that. But before that, to introduce quickly about myself, my name is Gopal and I head the sales for CISA, and I'm based out of Middle East in Dubai. And a few housekeeping rules. This webinar is about 60 minutes. 15 minutes we'll go into the topic discussion. 10 minutes we'll open up for Q&A. We have a Q&A session there or section there. You can actually type in your questions and we'll take it up at the end of the session. But before that, just a brief introduction about CISA. More of CISA, but a quick introduction about nevertheless. So CISA is a pure play cybersecurity company. We have been in this industry for the last 18 years, and our core focus is predominantly into the financial space where the threats loom large. And having said that, one thing that CISA takes pride is we call ourselves as a forensic-driven cybersecurity. We've got 2,000 customers across the globe. At any given point, we've got 1,000 plus active engagements that we do every year on year as well. We are recognized by Visa, Master, Amex, and we are one of the top forensic investigator as well. Just to show you a global footprint of where CISA exists, we have got offices in Canada, in US, and UK. We've got 4 offices in Middle East, which is Saudi, Bahrain, Qatar, and UAE. And in India, we've got 3 offices, and in APAC, we've got about 3 offices as well, which is Malaysia, Singapore, and Australia. So a quick introduction about the speakers today. We have Dr. Ranju Varghese, who is the VP for Forensics and Research at CISA. He's been with us for the last 18 years, and he's been spearheading a lot of initiatives with CISA. And he's currently heading the R&D for CISA. And also a brief about Ranju. He's got about 20 plus certifications. He's a CISP, he's a QSA as well. He's got a CISA certification. He's also a core forensic investigator. And as mentioned earlier, he's currently leading the leading tech with CISA. And then the other speaker we have is Dr. Anjan. He's also got about 18 plus years experience. He's also a PhD holder in computer science and engineering. And he has, in fact, authored quite a few number of books. So Dr. Anjan, if you can go to the next slide. Yeah. So he's also authored a couple of books, especially on research publications as well. He's also got the best research award in project and kleptography. He is also currently involved with CISA on IoT and cybersecurity and AI Prism, basically. He is heading as an associate director for AI Prism with CISA. With that introduction done, Dr. Ranjan, would you want to take it further from here?
Yeah, thanks, Gopal. Let's start for the prime focus of what we are here for the day, which is on the AI governance in action, and why is that AI governance makes it very important to focus on these part of it. It's only because of the point that the AI is intricately a very complex supply chain today, with composing of data, model, and the library and the application part of it, which is making it a very huge in terms of it. And to start, as a prelude to the artificial intelligence, the one thing which came very importantly was the machine learning concept, which was a basic building block of the artificial intelligence. And artificial intelligence from 90s and onwards have been viewed as a construct of machine learning and extension of it. Earlier, it was completely a predicate and an expert system kind of a picturization which was made with artificial intelligence. So the basic aspect of why machine learning, what's so important about machine learning, is that if you leave a AI agent or anybody in the AI, right, the way it basically learns is something which is very fascinating as a journey to predict something of it. Now let's take an example that how AI works and how it understands predicting rain and planning traffic part of it. So if you leave an AI agent or an AI bot as what you see on the slide now of how it predicts rains and plans traffic, this is how the process basically germinates and starts off with. So the AI basically observes patterns. Patterns are the very important building block of an AI algorithm or a machine learning algorithm, and how it basically reacts when it starts raining. So it basically observes that particular pattern. Next, what you look at is it basically constructs a rule which is on various elements and components which are there in that particular ecosystem, which is an observable pattern matching with the different components which is coexisting in that particular environment. Real life multiple different parameters and factors do influence this prediction, and that is where AI basically learns how it combines the outcomes and the parameters which are basically important, and see what are the end effect on its derivative or the inference what we basically look upon for it. So it basically matches thousands of examples, thousands of possible scenarios, combinations as what we see, and what basically happened during the complete episode of Rainik. And what were the different scenarios which basically came up with traffic, rain, and other aspects of it. Constructs its own rule engine with respect to it, and this is what finally happens. It comes up with a final prediction that 85% chance of a traffic jam when there is rain which is heavily there, and it's showering heavily on the city, and this is basically impacting the traffic to be very slow. So this is basically a way in which how the machine basically learns this particular construct by observing the environment and the ecosystem where it is being placed with multiple different observatory patterns. And also, one which is noticeably very important is that it doesn't stop there. It starts improving with its experience and becoming more accurate every day as what we look at. So it improves its accuracy over the period. To start off with, it may have started off with a very low score, and as and when we proceed further, it starts with a very high score. So it starts making things much more perfect. And then with that, it learns, adapts, and starts predicting of what it is and how things are, and how just like you check the weather before heading out, it starts working out with that. So in summary, when you look at machine learning, it is identifying a particular problem. Given a particular problem, what are its identifiable data sets and appropriate data set, what is required, what is a permutation or the computation that is basically required to learn with the required rule, pattern, and relation, which are very three triangular aspect which is required for machine learning algorithm, and then go ahead with the output of a decision, which is basically based on this in a very guided manner of this particular rules, pattern, and relations. So a summarized view of ML algorithm, which has been in discussion for almost 3 decades now, with different types of algorithm sets, starting from supervised learning, working on labeled data, where it is able to predict output with a linear relationship of what is required. And then we are looking at unsupervised learning, which is basically working on unsupervised data sets. Unlabeled data sets where there are customer segmentations and market as a very typical use case, which is very fast and efficient when there is a large scalable data sets and you have a model overfitting issue, which comes in with the typical supervised learning. And then we have a third category of learning algorithms, which are basically the reinforcement learning algorithm, which is basically a reward driven model, which is based on different states. Many of them would be the game playing agents which we see in the chess, and there are different candidate algorithms which are available under each of these learning type. I think openml.org is one particular platform where you can see a huge number of learning algorithms which are there under each of these learning type. So post this, we saw a huge change in the ML strategy, where the ML strategy started combining itself with the deep neural network and the deep learning network, where people started observing the brain pattern, and why don't we use a similar kind of a construct for learning algorithm as well. And that is where we started looking at deep learning to be a subset of machine learning, where we use the entire construct of the machine learning, where we had to use multiple different algorithms to do, say, for example, the feature extraction and the classification. But now that has been combined into multiple different neurons and multiple different layers in the neural network, which can basically perform the same task in a different way. So the key capability of a neural network is that it is composed of multiple layers, identifiably the input node layers and the output node layers. And there are a set of hidden node layers, which are basically used for the computation aspect of it. Each layer consisting of neurons, which can transform the output into something which is required in the output layer. And the output layer basically is the output derivative of this particular model, which can be a classification or a regression kind of a scenario what we are looking at. The neural network also, the beauty of the neural network is that it is an autocorrective network, which is basically on a feed forward and a feedback layer, which is on the forward propagation and the backward propagation basis. And the extension of this idea is where we came across with the transformer architecture, which became a foundation stone for GenAI, which is in the remarkably, which happened in the one of the conferences in 2017, where the transformer architecture changed the entire scenario of our machine learning and deep learning journey. And that is where we started with the birth of the large language models. And now we call it as GPT Cloud and many other public platform as what we see. So the simple anatomy of how transformer architecture basically looks is there is a two-stage process with the encoder and the decoder layers. The encoder layer is basically used for understanding the user input, because the machine has to be there has to be a mechanism where the machine learns about it. And that is a mechanism which is used, employed in the large language model, which we call it as the encoder layer, which basically helps in understanding what the input is all about. And the decoder layer basically assists in generation of this particular output, and what is the required generation that is basically required. So when you look at an encoder layer, it is typically composed of 5 phases, starting from tokenization, where the word is basically chunked out into different tokens based on different criteria, may it be a token based on words or characters or any other things, which is dependent on the kind of tokens what is basically supplied with. And then this tokens are basically converted into numerical embeddings, because your machine basically understand numbers, not the words. And that is where the vector embedding basically comes in with respect to it. And then the positional encoding, it is to make the machine understand in what positions does the sentence basically come in. And that is where the positional encoding works with. It's like the GPS coordinates of where we have to start first, which is the word to start off first, and then which are the remaining words that we basically look at. And then we have the self-attention layer, which is like detecting the and finding a clue and giving a primos focus on a particular word which requires a larger attention than the other ones. For example, maybe how are you? There are multiple keywords in this particular case which requires a different set of attentions for it. And then finally a feed forward layer, which basically calculates the attention between the words. It's like a personal calculator on each of these words of how they basically work, putting it down in a very simple terms. Then we start with the decoder layer, which starts with the self-attention of the outputs, which has been done, the cross-attention between the outputs, where there is an encoder decoder attention matching, which basically comes, it's like constantly referring back to the question and trying to understand what the question is all about. Then we go to the feed forward layer where we finally process it before the final decision making is done. And then obviously the final output prediction part of it, which is a probabilistic function, which chooses which is the best word to be placed for this particular sequence, what needs to be generated. So this is the overall anatomy and the very basic foundation of how Gen AI basically works. And we have multiple different real world examples, which basically talks about how tokenization works and how the different layer basically works with respect to it. And there are multiple visualizations that are available out there to basically understand and rip apart the every layer and every process, what basically happens in this transformer architecture and how it basically processes this and what are the intricacies which are basically required to understand each one of these stages. So the traditional machine learning is a case of someone trying to work on a car driving part of it. Okay, let's say that we are trying to do a manual car driving. It still requires a human input, human supervision to function, where there are multiple controls like gear stick, clutch, brake, and accelerator, which needs to be controlled manually by a human intervention. So that's how the traditional machine learning is a analogous example too. But when we went ahead with the ML systems and started improving upon with respect to it, we started automating this particular process and making the car less manual control and more of the automation part of it. But it still requires a lot of control, which is required to drive this particular car. It is not completely automated. So that is when we moved across with the generative approach of it, where we started looking at the adaptive cruise control and the ADAS functioning of it, which is an environmental driven part of it, which adapts and handles the task dynamically, which was with respect to it. But our goal was not this, but we started with that. But finally, we came across with the agentic AI construct, which is resounding everywhere now with the autonomous vehicle concept with a LiDAR technology, which can combine multiple different subsystems and try plan, decide, execute, act independently to achieve this particular goal where there is no driver on the driver's seat. So you need to trust the entire vehicle to go ahead and sit inside and start working out with a Waymo car or any other driverless car, what we talk about. So the agentic AI basically works with the multiple different layers with multiple different perceptrons, which are basically required with a large amount of prediction engine at the back, where there is a decision making and the control, which is basically works like a human brain in the car and trying to work with the perception with multiple input layers with camera, LiDAR, and other technologies and actuators, which are basically required to action out every decision making what is basically done. And then there is a planning and a prediction module which basically works at the background, which is executing what is the plan from the map and trying to do a prediction of where it needs to reach. And then there is an orchestration decision engine which takes a very important role in combining and amalgamating multiple different machine learning models and large language models to achieve this particular objective of a driverless automated vehicle or an autonomous vehicle, as what we call, through a completely agentic system architecture with respect to it. This construct is a very important construct, which leads a very important point to the second part of how do we stitch this applications with it. Over to you, Ranju.
Sure. Thanks, Anjan, and good afternoon, good evening to all. So let's talk about how the LLM is being used within the various applications. Please note that we have actually gathered these informations from various interactions with our clients. So if there are anything which is new and out of which you're not able to cover, because this is an evolving phase, right? So we try to cover most of the applications deployment using LLM. So in a traditional application, you definitely have the user who's going to interact with an application which has all the logic part, and we do have the database in the backend. In the initial phase, when I'm talking about is in the 2010 onwards, we had the ML algorithms, right, being incorporated within the application as part of an application workflow. Think about your Amazon Alexa, think about your uh, iPhone Siri. All these were an ML algorithms which was basically triggered as part of an application workflow. So here, apart from the text being provided by the user, we had the image being shared across, we had voice for sensory data, which used to be processed via the ML algorithms, and then the application used to take it forward. Some of the live examples are basically ML used in a lot of fraud monitoring in the banks. So we had a lot of ML algorithms for identifying any anomalies with regards to the normal transactions. If you talk about security monitoring or security space, we had ML algorithms in our SIM solutions or UEBA solutions, where the ML algorithms triggered as part of the application workflow. Then came our ChatGPT from 2022 onwards, right? So the first deployments that we had seen once GPT came into picture was the clients directly linking an LLM to the application, mainly as a direct chat interface. Please note that when we talk about LLM, here the LLM can be deployed in two ways. One way is the organization can directly call the API of LLM providers like OpenAI, uh, Gemini, or Cloud.ai, etc. Or you can actually download an LLM from platforms like Hugging Face and host it within your environment or within your cloud environment part. So the initial deployment of integrating of LLM, which we saw was the clients directly giving it as a interface without any client data part of it, but just providing as a direct chat interface to the clients. The second type of deployments that we saw was basically in the outsourcing industry, your BPO, your KPO industry, where they used a combination of ML and LLM for their function. So, for example, in the outsourcing industry, in the BPO, we had the calls being recorded, and the calls being using the ML algorithms is being changed from the voice to digital, and then they've been sent to an LLM for basically summarizing the calls and other details. We also had the image in a KPO industry where the doctor's prescriptions is being scanned using ML, able to extract the data set, and using an LLM to do a quality check of that particular extracted data so that it knows that, okay, proper a prescription has been given by the doctor. So this was the second type of deployments that we have seen where both ML and LLM was being integrated together. The third type of deployments that we saw was the application directly using an LLM as part of a application workflow, right? So basically, whether it is for sending any documents to the LLM for analysis. So the initial deployments that we saw was for your human resource application, HRMS application, where the HRMS application used to review all the resumes and based on the requirement of the job description, give a confirmation whether the resume met decision or not. So this is now being used quite a lot where in case if you want to make a decision, this kind of deployment been seen. So it's been seen to validate whether the loan applicant is proper. So they just used to send to LLM and based on few of the parameters, get a response part. In HRMS, the entire resume screening and everything is being driven through these LLMs. And as we go forward, we'll see a lot of these kind of deployments in various of the SaaS applications as well. So till now, we always been sending the user inputted data, whether it is a voice or a document, to the LLM uh, and getting a response part of it. We'd never had the user data, right, which has been within the applications being used for making a decision. And that's where the RAG came into picture. So RAG is a retrieval augmented generation method. So it is like a database. Just that difference is that instead of our normal rows and columns in our database, it is a vector database. It's in a vectorized format. Similar format which is been running in an LLM. So in this case, the organizations basically uploads their data set, right? Like the policy documents or your SOP, standard operating procedures, everything into a RAG system. And when a user runs a query or when a user interacts with the application, the query is being routed to the RAG system. And from the RAG, based on the query, the relevant context is being picked. And then both the user query and the context is being sent to LLM for giving a response back to the user. So in this method, you have a lot of organizational data can be linked to your application so that your accuracy or your relevancy to that particular user's query becomes very important or becomes much more accurate. One of the initial deployments that we have seen, or most of the deployments that we have seen, is where uh, the organizations are using their internal documentations, right? Like the HR policies, their standard operating procedures and everything into a RAG, and then providing it as a level 1 support function to the employees to interact and get the relevant queries back. Then the most kind of deployments that we have seen is where the NCP or the multi-context protocol coming to picture, where the entire application can directly interact with the database and get this relevant information and use it for direct user query. So in these kind of deployments, we have seen is that whenever there is a initiation to the application, whether it is inputted by the user or is being triggered within the application workflow, the application sends the relevant or sends that particular query to LLM2, right? And ask that, okay, to answer this particular query, give me what data should I search in my database and pull so that I can answer this particular user query, right? So here, please note that in the step 3, which is mentioned, we basically are asking the application just sends that initial prompt to the LLM2 stating that this is the query which I received from the user. What database tables or which database columns should I query to fetch relevant data so I can answer this particular query on a more accurate manner? Your LLM2 sends that, okay, these are the database tables to query. And your application basically fetch that particular query statement, queries your database, retrieves those relevant information, and then along with the user inputted data or within the application workflow, gives that user prompt plus this particular data retrieved from the database to LLM1 to respond back to the user. So in this manner, you can actually tweak it so that your entire AI applications become much more user-friendly and customer-friendly, right? Say, for example, in case of, let's say, an internet banking application, right? When the user says that, okay, I want to retrieve my bank statement, the application basically going to query, send the first request to LLM2 saying that, hey, user wants to retrieve his bank statement. What all tables and what all should be my query statement? It receives the queries. It receives the query statement back, queries the database, retrieves the data, sends to LLM1 for responding back to the user. This can be expanded more to integrate multiple database. So there is a construct called MCP, a multi-context protocol with multiple MCP client and MCP server. And this construct can be expanded to multiple applications and multiple database with one just AI interface. So that is, which is the most commonly seen AI deployment that we have seen in the uh, within our clients in the past a few months. Now, just a few use case, right? So till now we've been talking about how AI has been integrated into application, but these days you'll definitely hear the term agentic AI, right? So we like to just give an example of how CISA have implemented our agentic SOC and incorporate agentic AI within our product called Proact. So we provide a monitoring service and how it's been integrated. Please note that just the use case, the same thing can be deployed across your applications as well. So initially, for our SOC use case, we just had the logs, which comes as data. We had our ML layer, which was basically a rule-based layer. And sorry, we had both rule-based layers like your alarms, correlation rules, and we have our UEBA layer, which used to generate the alerts. Now, in every SOC, definitely you have a scenario of getting a lot of alerts. So our goal was to confirm whether the alert was a true positive or a false positive, and what action has to be taken to mitigate that particular incident. So in our initial deployment, what we did, we used something called as the chain of thought prompting. These are basically prompting prompt techniques on how we can interact with the LLM. So we just initially we just send that, okay, just got this particular alert and said that whether analyze this particular alert and confirm whether it is false positive. And if you're not able to confirm, then get additional logs for analysis and confirm part of it. So if the prompt says that, okay, the LLM says that I need more data, I need more data sets to analyze whether it's a false positive, true positive. We used to get the ask for the Elasticsearch query. Why Elasticsearch query? Because we use Elasticsearch in our backend. And we use that particular query statement to fetch those additional logs and then again send it to the LLM to confirm whether the alert is a true positive or a false positive. It worked, but there were some few limitations, because one is that it was the entire thought process was limited based on the chain of thought prompts, right? And we need to have a lot of prompt engineering techniques to be used continuously. It was not self-learning, because if the client had similar incident earlier, then they were not able to understand from that and respond, nor it was dynamic in nature. So most of the clients, when they went for these initial deployments, had similar challenges with their applications. And that's where the agentic AI came into picture, right? So here we're talking about the agentic SOC use case. Please note that the same agentic infrastructure can be deployed for your application. Just for an ease of example, we're just giving this particular use case, right? Sure. So here again, we had our data layer where we basically consist of the logs. Now, all the logs used to be gone through our agent one, which actually is nothing but our ML algorithms. So we had various ML algorithms, UEBAs, our correlation rules, rule-based, and everything. Now, once that particular alert got generated, our goals remain the same, right? The goal is to identify whether the alert is a true positive or a false positive. And if it's a true positive, what action should be taken to mitigate that particular incident? So with that, we brought in something called as the orchestration agent, or the main brain agent part of it. So the orchestration agent, which is again an LLM, used to just orchestrate or just route that entire workflow uh, of the system. So once the alert goes to the orchestration agent sends it to an agent 2. An agent 2 we basically used was a another LLM, and its main functionality was just to basically triage that particular alert into more details. So that was the agent 2 function. It was just basically triaging that particular alert. So here we used a Falcon LLM. Now it has been changed to Llama, which is a good LLM for just triaging that particular incident. Now, once incident has been triaged, it was being sent to the third agent called an investigator agent, which comprised of LLM and a RAG in place. So RAG is nothing but a vector database system part of it. Now here, why it becomes very important is that in this particular RAG, the RAG contains all the historical tickets and the security incidents of that particular client. It includes what the client in architecture is, what was the latest vulnerability report of that particular client, what is the current security posture of the client, what all preventive controls has been implemented by the client. So all these details is being there in that particular RAG. So when the triaged alert goes to that investigator agent, the investigator agent has a lot of these particular data in its memory by part of the RAG, and is able to analyze that particular incident in a much more in-depth manner. And if the investigator agent wanted more details, instead of fetching it from the logs, it can basically integrate with the existing tools of the client. So we had an agent 4, which is nothing but an integration agent, which used to integrate with the existing tools of that particular client. Now, if the investigator agent want more details, it can actually query to the agent 5, which is basically a threat intel agent, which can be query the internet and fetch this additional threat intel database and get more inputs to the investigator agent. Now, once the investigator agent completes its analysis, it goes to agent 6, which is a QA agent, again LLM, which basically is uh, analyze that particular incident and analyze how the investigator agent have analyzed that particular incident and confirm whether the QA methodology or the it's been properly analyzed. So it's basically a QA function. So it's been again driven by a QA agent, and based on the feedback, it gives that feedback back to your agent tree, which is again go and sits in your RAG. So in that manner, it is actually has a self-learning loop. And in case if there is something missed out, your QA agents can actually go back and update the agent tree to make further analysis in a much better manner. Then we had the agent 7, which basically is nothing but a SOAR function. So it's again an LLM with a decision tree in place. And in case if any action is required to be carried out, the action is being getting driven through the SOAR. So in an agentic AI setup, it is not only just an LLM which is being working. It is a combination of your ML algorithms and LLMs, your various tools and other application logic, which can be combined together to form an agentic AI setup, right? So thereby able to meet quite a lot of your or automate a lot of your ability, and also enable it to think like a particular human being does. So this is just an example of the agentic SOC. The similar deployments can be done for your applications. So once everything is being deployed, right, and your application is agentic AI ready, then comes the construct of being ensuring that it is a responsible AI part. Over to you, Anjan.
So this is the point where we start off with how do we make AI a responsible AI? Having looked at its widespread inclusion and adoption into multiple different applications, it becomes very imperative and important to make AI as a responsible AI throughout its journey. So, looking at the multiple different components and multiple different definitions across multiple standards and regulatory body and governance, and even OECD also coming up with AI principles, talking about what is basically responsible AI and what are its traits that it basically need to exhibit to be called as a responsible AI. That is where we see an inclusion of bias and fairness aspect, fair and not being biased, to be included, where the model is fair in making its decision and not biased to a particular demographic group or a particular attribute in that particular data set, which is basically trying to ensure that the decision making is not erroneous and it is not biased with respect to it. The second part of it, it's also very important to be transparent in terms of AI and make how decision making process of AI understandable, interpretable, allowing businesses to explain why this decision was made with respect to it, ensuring that there is a factor of trustworthy inclusive of this particular point, which can ensure that there is a trust that can be built with the AI system. A third, of course, is the model security part of it, where the model is hardened in such a way that it is um, robust against any kind of adversarial attacks, ensuring the data and the model inference, what is basically looked at, is of a very high integrity, and it's crucial in safeguarding the model's sensitive data and also the trained data of the particular model, ensuring that there are no reputational damage and no significant loss in terms of it. Also, in we have seen a lot of use cases, the use case of AI being used in a driverless car, another case, where safety becomes a paramount concern. And that is where AI needs to exhibit a safety parameter component, ensuring that it is safe at all points of time and it is robust against any kind of attacks in its environment. And of course, the data which is used for training that particular model should be ensured that there is a privacy protection ensured in it, and it does not use any kind of PIA or a PHI kind of data in trying doing it. And there is a lot of regulations that are basically governing, inclusive of GDPR and other similar kind of regulations. And sixth important pillar that we look at is the AI to be free from all kind of toxic information and should generate something which is legitimate and acceptable by all of them, and ensure that the system is potentially taken off with all of its toxic layers, trying to talk about harmful, biased, and offensive outputs which are basically used in it. And seventh important part of it is AI today, although we speak about AI and at large language models and many of the GPTs, they all have one of the things which is in common, which is the hallucination. That is, the model is not accurate enough in putting up its information and trying to predict what is required correctly, which is required for that particular application, where a factor of the trustworthiness is also associated with high accuracy models. With this, Ranju.
Sure. So we talked about the how to responsible AI, what are the different parameters of responsible AI, right? Now, as a security professionals, how do we prepare for the Gen AI applications? How can we ensure that the Gen AI applications are secure, responsible, and trustworthy? To initiate, right, the first step in any system is to ensure that it is secure. So how can you ensure that AI is secure? The first step is identify whether the AI system has any vulnerabilities, right? Vulnerabilities like your prompt injection, toxicity, or an evasion attacks part. How do you do that? The same can be done by conducting LLM red teaming activity. It can be conducted using GenAI application red teaming activity, pen testing of your entire AI system infrastructure, or the continuous LLM red teaming construct, which is there in the market. So it's basically to identify what kind of vulnerabilities are present in your AI systems. Now, once you identify the vulnerabilities, how do you patch it up? Sorry, yeah. So the other, the risk to be identified is one of the risk on the your AI infrastructure. The second thing is that to identify the risk in your data which has been used by your AI system, right? Now, if your data is not proper and it has a lot of bias incorporated, then the final output can be lead to a biased decision making part of it. And some of the data that if you're fed into the AI system has any confidential data, then it can actually lead to a lot of PI data part. How do you do that? How to identify the risk in your data set? Is basically doing data scanning part of it, data scanning for identifying whether any confidential data is in your data which has been uh, used by your AI system, and whether the data has any kind of data bias which has been there. There are various tools in the market which can actually do all these activities. Now, once you identify the vulnerabilities, what's the next step, right? The next step is going and mitigating those particular vulnerabilities. So for mitigating the vulnerabilities in your AI, or basically in LLM, you can actually go for secure fine-tuning of the LLM, right? So it means that your LLM, you're actually securely fine-tuning it so that it is not vulnerable to these injections. Think about it's like having your uh, vulnerabilities or having think about like your vulnerabilities in your operating system and you patching those operating system part. Um, Amal, maybe you can just raise your questions in the Q&A session. We can just type it in here, Amal, and we can answer that. Yeah, sure, thanks. These so once it's been fine-tuned, the next one is securing the AI architecture by design. So there we have something called as the LLM guardrails. So guardrails are basically a specific set of rules which states that what the AI system should not do above or should not do beyond this particular specific functions, right? So you can have the LLM guardrail specified so that your LLM or your AI system doesn't go and do beyond its specified set of tasks. We have LLM firewalls, which you can recognize it as like your WAF, web application firewalls. We do have LLM firewalls, which can actually uh, analyze the request and response and prevent these injections being going out. And we have definitely the secure ML ops and secure data handling aspect. So once you mitigate those particular vulnerabilities, you can rest assured that your AI system is secure. The other second step is to ensure that how to ensure that it's a responsible AI, right? Now, one of the main points of responsible AI is basically is to ensure that the AI systems performs within a specific set of goals and guardrails. Goals specify what an AI system should do. So if you take the example of our agentic SOC, we had the goal of specifying that to identify the alerts as true positive or false positive and take actions if the alert is a true positive. Guardrails is basically a set of uh, is defining the limits to which that particular AI system can autonomously take any actions, right? So to do that, you can definitely deploy your guardrails part of it. But more important, you need to ensure that there is an observability component added, right? Monitoring of the AI systems. By you can have observability AI deployed, which ensures that it monitors all the request and response from an AI system, and it can be used to identify any adversarial attacks because there's been new type of attack patterns evolving, and there's a chance of new attack being launched. You can ensure that any kind of anomaly input detection can be identified, and in case if there is any kind of a data or model abstraction attempts, you can able to monitor it and able to identify the same, monitor if there is any confidential data being leaked, monitor if there is any model drift, right? So one of the biggest operational challenge in the AI applications is that once systems are goes live, there is something called as a model drift or data drift happens, which means that the models and the data drift from its predefined goals. So you can able to observe whether the systems has any drift being added. and more importantly, confirm that the AI systems has not gone beyond the specific defined set of guardrails. The third one, so once you have secured AI systems and ensure that there is uh, observability AI deployed, you can ensure that you can go for a trustworthy AI by going for your ISO, the ISO 42001 standard, right? So basically, there you can initiate the activities like conducting an AI risk assessment. We can conduct the AI inventory scan to identify all the AI systems which has been deployed within your organizations and identify and secure the same. And also the same thing can be spread across to your third parties, right? Like any vendor or any third party who's basically support your infrastructure or any applications or any SaaS providers who provide these uh, any of the SaaS offerings with this AI integrated. You can ask them to be ensured that they are ISO 42001 compliant, which ensures that their AI systems are is a responsible AI component. So till now, we just covered a very high level view of the same. If you want to more details, we do have our own workshop called Certified Security Professional in AI or CSP AI workshop. Sanjan, you can give more details on the same.
Yeah, this is a very important part of equipping people and upskilling ourselves with respect to the security controls that is basically required in AI. And it's basically a thematic area on cybersecurity for AI and how security control matters in terms of AI. The Certified Security Professionals in AI is a world's NAB accredited program. In fact, world's first NAB accredited program and a top class premier program in terms of delivering in cybersecurity for AI. Here in India is being endorsed by certain. The typical coverage of this particular program starts with the introduction to AI ML and dwelling into large language model with the concept behind it, and then also looking at how what are the different ways to customize this particular LLM with respect to fine tuning the LLM models, applications within the LLM usage within the application, and what are the different architectural styles of using it. Future of Gen AI, LLM vulnerability exploits, where we basically cover OSWAP top 10 LLM vulnerability, MITRE Atlas ML framework, and Google Secure AI framework, and of course, CISA's patent-pended approach of risk assessment and governance framework with the AI-driven process of it, and also multiple different GRC framework, including UAI Act and ISO 42001, and NISTI, RMF, and multiple such kind of topics. But to know more about the program, you can basically scan this particular QR code, which you see on the screen, which can basically give you a larger insight about this particular program and why is it important for security professionals to undergo this. Not just security professionals, in fact even the compliance and auditors, policymakers, and cybersecurity experts, AI engineers, as a very important step in understanding the AI verticals and how do we basically secure on it, understanding different GRC frameworks as well. So we can also connect online in LinkedIn, and if you have anything that we can talk about in the AI cybersecurity for AI world, we can just connect with me. You can scan on the QR code, and here we have the upcoming workshop, which is starting from July 23rd to 25th, which is starting at 9 a.m. GST Gulf Standard Time and ends over at 4 p.m. On the first 2 days, and the last day it is typically a half a day, which is a recap. With that, I would also like to touch upon the wide variety of solution stack of CISA that we basically cover upon, which is starting from the compliance to the leading tech security, which is touching upon the emerging tech security part of it. And with that, thank you so much for this. And it's now time for a Q&A.
Sure. So if you can actually post your queries in the Q&A box, we like to we'll answer that. So the one query is that can we get this presentation of this section? Yes. After this session, we'll be sharing the details. Also, the same is being available in the YouTube as well. It's recorded live, so you can actually access it as well. If there's any further queries, request you to just type it in. Sure. The other query is basically on it's for Ranjan, is basically on how do you want to know more about the certification, right? Maybe Anjan, you can just go to that
Yeah,
QR
sure.
code. Maybe you can just scan this QR code. You can actually download the brochures, and it has all the details about the workshop. Do we need the other question by Bethlehem is that do we need specialist governance for any extension to handle AI-based security? Uh, Bethlehem, to answer the question, you definitely from a system from an organization aspect, definitely you might require someone who knows about this particular AI system and can ensure that when the organization implements or your vendors implements the AIs in place, you can go ahead and ensure that it is being secured and responsible. And this entire workshop, CSPI workshop, is to ensure that we train the current set of security professionals to handle that particular AI-based security and governance role. Based on the summary with your clients, which LLM Gen AI is mostly secured? Like to answer that?
Yeah, I think none of them are completely secured, and you see a lot of vulnerabilities even with the most hardened model as what we speak. And there are different approaches of doing that so, but to be very generic and realistic, you don't see a mostly secured LLM even in any kind of model hubs, including Hugging Face or any other place.
Sure. Having said that, we have OpenAI, Cloud.ai, and Gemini and Microsoft having a huge team to ensure that their models are being secured, because we do have our own LLM red teaming team, and we keep on identifying new type of ways in which we can break the LLMs. The other question by Joe is that is there any uh, tools for security scanning of AI applications?
So there are multiple different approaches of scanning the AI applications, because today's AI application what we are looking at is a Gen AI application composed of LLM. So the core component is to scan the Gen AI, that is the LLM part of it. And there are multiple open source tools which are already available in the market, which can basically scan it and find out what are the vulnerabilities. And there are at least a dozen plus metrics which is basically looked upon to understand the health of that particular LLM in terms of its goodness to be incorporated into an Gen AI application.
Sure. The other question is that in a multi-agentic environment, how do you ensure if the agent in the workflow is actually action on the instruction part? A good question. So there are multiple tools which are available for an agentic AI construct. One is the LangChain library, which is an open source library, which actually ensures that the entire agents works as per the defined parameters. That we are more focused on security part of it, but if you go from an application development aspect, LangChain is there. There are multiple other similar libraries which you can ensure that the various agents workflow part, right? So the major component is the orchestration agent, which ensures that every agent works in its defined method. The other question is, how does securing AI approach map to standards such as ISO 42001?
Okay, so this question is a very important focal point because many of the organizations are looking out for ISO 42001 part of it, and it's very important that the journey of the ISO starts with a responsible AI construct, and for responsible AI construct to be achieved, at the layers below it is the securing AI approach, which is a very fundamental aspect, which is basically covered even in the ISO annexures as well. So ISO 42001 is a multi-phase activity with AI literacy a part of it, and there are multiple approaches of auditing the AI and trying to find out what are the risks with respect to it.
Sure. Joe has another question is that can we actually discover any risk in AI applications before seeking assistance from security specialists of AI? Uh, yes, Joe, I think definitely you can use the various scanners to identify the AI application risk part of it. So like we mentioned, the first thing to consider is securing your LLM. If your LLM is secure, then you actually able to address 80 to 90% of the problem, right? So because the source itself is secure. And then it's about the guardrails. So then once the guardrails is being configured, you can have an audit of your guardrails, how the guardrails been configured and everything. Then as a third assurance, you can do an LLM red teaming to ensure that all your controls are being properly working. So that will be the approach part. Jagaran has a few questions. Question is that what are the risks of using public LLMs like OpenAI via APIs instead of private LLMs for an enterprise use case? Can these public LLMs pick internal organization data? If it happens, how to make these LLMs forget this info? Wow, that's a good question, Jagaran. So just to answer that one, most of the LLM, um, also the OpenAI providers mentions that they don't use the enterprise data for their training data set. They cannot able to pick the data unless you're going to pass this particular data set to you to the those OpenAI providers. They will not able to pick it. It's all about what data or what kind of details you provide them across. But these days, most of the organization which we have talked with, they basically integrate with these OpenAI providers during their POC stages to ensure that the entire agentic AI, that entire construct works. And once the POC stages passes, then they use the LLMs or SLMs, small language models within the organizations to run when it goes into production. The reason being that they have much more control over it, and it also ensures that from an enterprise perspective, they don't they can comply with multiple standards and ensure that the data doesn't goes out of their organizations. Having said that, they also the OpenAI providers, especially the Microsoft Copilot, they say that they can host it within their countries so that your geolocation or the data doesn't goes out of your geo part of it. But it's a question, it's a call which organization should take, right? If you're in a regulated industry and you have multiple audits and compliance standards to comply with, we recommend to go with a private LLM than an open LLM to ensure that your life is much simpler. Thus, thereby also making sure that you can able to meet that goal. The other aspect is the cost, because when you're going to talk to this OpenAI, for every token that you send, there is a charge, right? So that cost can actually scale up in very short period of time. So with that, we have two more questions. So we are already over time, but we'll just answer these questions because answering all queries is one of the most important aspect. Are there any benefits of using RAG over MCP? Uh, it depends. If you have, say, more organizational data, which is like standard policy procedures, then RAG makes sense. But if you want more details like a customer info or a client, a specific user info and everything, or if you want to directly query from a database, then MCP makes more sense. So it again depends on what kind of deployment you want. You can consider both RAG and MCP. RAG works well if it's combined with LLM, and like a standard query, you can actually fetch more details. RAG makes a lot of sense. But if you want other multiple systems to be interacted, then MCP makes sense. Other question is that, so which is better, an in-house private LLM deployment or an API integrated to Copilot? Uh, it depends on organization and the use case that you have. Uh, uh, there is, if you actually, again, use OpenAI or Perplexity, there are a lot of metrics that you can use. So where, in which use case you're using, which application you're using, the answer differs. The answer is not same for all deployments part. Our opinion, that is both our individual opinion, not CISA's opinion, is that if you are in a regulated industry, a private LLM makes more sense if you face a lot of compliance audits and everything. But otherwise, you can definitely go consider OpenAI because go to market is much faster in an OpenAI integrations. The last question, would you know if there are any directions on LLM requirement to be in place under PCI DSS? A good question. Currently, this is an evolving space, and there is no specific requirement coming from PCI saying that, okay, these are the controls to be deployed for LLMs and everything, but it's an evolving phase. One thing we know that most of the central banks are working on a standard to ensure that if you're integrating AI within your applications, they're secure and they're bringing something similar to the lines of ISO 42001. But right now, there's no mandate right now. The only one which we are aware is that the Singapore MAS, Central Bank of Singapore, do have a regulations. We know for a fact that the Central Bank of India, RBI, is working out on something for the regulations. For other central banks, we're currently not aware or it has not come out yet. Sure. With that, thank you all. Thank you for attending our webinar. And if you have any further queries, please do reach out to in LinkedIn and you can drop a message to both of us, or you can drop an email to us at sysinfosec.com and we can able to answer your queries as well. Thank you.
Thank you. Thank you.